looking at the soil biology in comparison to different soil types and different cultivation systems.
Okay.
And how that affects the crop growth, actually.
Okay.
And how you can improve that to make it better and make your maybe reduce your inputs or something,
Yeah.
so that you can then sustainably manage your system better.
Okay.
So part of what Richard's doing with the amino A is where he's bringing amino acids into the mix, so spraying them onto the crop. The crop can then use those amino acids instead of producing them themselves and using energy to produce them themselves. But also some of the microflora will use the amino acids as food, and then you get that microbiome system working more effectively.
Okay.
So yeah, that's.
What do you want to kick off with your company and how you interact with Richard?
Yeah, what we've done here in a way is where Richard's on Simon's estate, where he's done a lot of work, who's using a zero till with that drill system, the Triton drill. We did a soil sample just recently to look at the biology on his zero till. Okay. And then we've also taken a sample from here and looked at the soil biology here, which has a much more conventional system of cultivation, which is using sort of plough, power harrow, drill, that technology. Whereas by non-disturbance, you can improve your microbiome significantly. Because in each that handful of soil.
Are we recording this?
Yes.
Right. Okay. We'll
So
start
we'll
with.
just carry on,
Right. Yeah. In each handful of. Yeah.
So in each handful of soil, in there, now this is from there, I've just picked it up. It's got probably over 1 billion bacteria. There's probably 3 or 4 yards of fungal hyphae threaded through it. There'll be, ideally, and there isn't in this particular soil, but ideally you'll have probably 30,000 protozoa, which are tiny little almost single-celled animals, and then maybe 7 or 8 nematodes in that. So that's what's going on in the soil. Now, what we found is that soil from here had reasonable numbers of bacteria. The same as. So this is sort of the results from Simon's zero till field in Cambridgeshire. So he had good levels of bacteria. His fungal activity was reasonable, and in that soil, good levels of bacteria, fungal activity less. He's got some really nice levels of protozoa here, and the nematodes were okay, not brilliant. The key is the protozoa really for the recycling of the nutrients. In this soil type, where they've used more conventional systems of cultivation, very little protozoa, very few nematodes. So what happens is that the plant itself chucks down root exudate, and up to potentially 40% of the energy that crop captures through photosynthesis gets pushed down as root exudate to feed the microbiome, the bacteria, and then the bacteria themselves actually lock up those nutrients, so they don't become available to the plant. So they're giving the bacteria carbon. That's what the bacteria want. And then what happens is that the protozoa come along, eats the bacteria, and there's too much nitrogen in the bacteria for a protozoa to use, so it excretes nitrogen and other nutrients, but nitrogen's the main driver of crop production. And then that comes out as in an ammonium form. That gets converted by the nitrifying bacteria around the rhizosphere, and then the plant picks it up. So that's the sort of basis. And some of those root exudates will have amino A, not amino A, but amino acids. The link with what Richard's doing and amino A is that the amino acids can help feed that microbiome as well. So They have a lot of other effects on the crop outside of the microbiology, but they do help the microbiology as well.
I think I understood what you just said.
But
don't test me on it.
It's a very complicated story, and we certainly don't have all the answers.